Concurrency design patterns represent a family of patterns aimed at synchronization and optimization for multi-threaded applications. The active object pattern focuses on decoupling method execution from method invocation, where methods executed on a separate thread from the invoking thread are synchronized through queues. The major components of an active object implementation are the client, which is the main hosting application, the proxy, which exposes the public methods that the client can invoke, the method request, which is typically a runnable object that contains the actual algorithm that the decoupled execution thread will run, the activation queue, which buffers method requests to be processed, the scheduler, which handles activation queue loading and unloading, and the servant, which defines the functionality of the active object class. It provides concrete implementations of the proxy methods and the corresponding method requests, and is also composed of the various synchronizing classes. Also, futures can be used to provide two-way methods with return values or objects. This UML-like diagram illustrates the generic implementation of the active object pattern. The client has a proxy. The servant implements the proxy interface and has a scheduler. The scheduler has an activation queue, a queue loading method, and a dispatch method that handles queue unloading in a dedicated thread. The concrete method request is an abstract method request, and in some cases has a future for two-way method implementations. Let's look at an example application for the active object pattern. An augmented reality, or AR, software application is being designed for a heterogeneous multi-core processing system. The system's target processor contains two cores, a low-power real-time microcontroller core and a high-power application processor core. The application needs to access accelerometer sensor data from a hardware controller thread running on the real-time core and display the sensor values on a UI thread running on the application core. An active object solution will provide the application, which will be the client, with a synchronous way to invoke methods to retrieve sensor data from the low-power thread, which will be the servant. The UML-like diagram on this slide represents the active object implementation of our AR sensor application. The augmented reality application is the hosting application, which has a sensor data component. The sensor data component provides public methods for requesting sensor data. The accelerometer service is the active object. It implements the sensor data interface and has a sensor request scheduler. The sensor request scheduler has a sensor request queue for buffering accelerometer requests. It also has a sensor request queue loading method and a dispatch method, which would run on the low-power processor core and handle unloading accelerometer requests from the sensor request queue and processing them. The sensor request abstract class promotes polymorphism should a new sensor model or type be implemented in the future. Thanks for taking the time to learn about the active object design pattern. Please check out these references if you want to read more about this or other concurrency design patterns.